Hello, welcome to this series where I am programming an NES game live on Twitch. Here tonight, this is stream number 39. And just a little announcement if you haven't seen already. I just posted the first in what I'm calling the Zero Pages or the Zero Page series, which is shorter videos that I'm going to be doing about NES programming, just kind of getting to the bare bones bits on how to program for the NES. As you know, if you've been watching these streams, they tend to go long, and so I thought it would be good to kind of take what we've done in all of these streams and put them together into a shorter series of videos that cover specific topics to help people learn NES programming and kind of understand better what I'm doing here on the live stream. So keep an eye out for those. I am putting them into their own playlist on YouTube so that they can be more easily found. Yeah, hopefully they'll be helpful and people will want specific topics, and I'll try to cover those to make sure that the videos are useful. So let's get started. So last time we were working on loading the attributes into the attribute memory for the game, and we made some progress there. When you progress through the level, you can see some of the palette colors look okay, but they're not exactly right. It seems like there's some sort of issue with the way that the colors are being loaded into the attribute memory as we load rows into the name table. So like that, these blue tiles should actually be a dark blue like they were when we first started the level. You can see they're a dark blue here, and this is the purple that they become, which is actually the color for these gradient tiles. So let's work on figuring out why the attribute colors are not being loaded in properly. Let's see if we can get that done tonight. So if we go back to our code that was dealing with that, there are a couple of parts. So we had the code here that was dealing with loading the actual rows from the meta tiles. And then, based on whether or not we had skipped into a different row of meta tiles, you'll remember that when we're dealing with the loading of the screen as we scroll, we have the row of meta tiles, and we have a separate line of the smaller 8x8 pixel tiles that we're rendering. So we'll do one of these rows at a time, and then eventually, after we've done 4 rows, we then get to the next meta tile. And so when we get the next meta tile, we need to set the attributes here so that we are our tiles, our meta tiles, look correct. And the good news was that the initial load of the screen, obviously we're loading the meta tiles properly there. That's the easy part though, because the meta tile information, the attribute information, is loaded, preloaded and directly written just right down the memory into the level 1 file. So there's not really that much to do there. It's pretty straightforward. We know that that part's working because we can see that the dark blue color that we're getting for this tile is in fact the same color for this palette, which is what we're supposed to have. So the question is, why, when we're scrolling, are we not getting that? You can see here it changed this attribute, this part of the attributes data, to the wrong palette, because this should be the same blue color the whole way through. I'm trying to think what's the best way to kind of troubleshoot the problem. I think what we will probably want to do is just alternate the different meta tiles just for the sake of our testing here, because it's going to help us identify where and how off we are with the way that we're loading. And so let me do this. Let me can I just do that? I can. So I know, for example, the first screen is, at least it seems that it's correct, because it's getting, it looks like the palette colors are what we would expect. So if I go to here now, oh, I missed one. So now if we go to here and we do, we're just going to do alternating patterns in a succession where it makes it obvious that we've loaded the right tiles and the right palettes. I don't want to just do every other, because there could be some sort of bug that happens to align that way. So I kind of want to space some things out, and then I don't want to make it the most simplistic case in this particular instance, because it will then not help us identify the problem. So we're just kind of spacing out these tiles here to give us an idea. Now it's also going to help us see the progression of the level, because we're going to see the gaps occurring at regular intervals. Oops, I didn't want to do that. So and I know this is not the most exciting looking stuff, but again, this is kind of what we need to do to make sure that we have all of the basics working on the technical side. And then once we have that working and we're satisfied with the way that's functioning, then we can jump to more of the actual level design, collision detection in the level, other things, the different aspects that actually make game design probably more challenging, I think, because the technical stuff is usually straightforward, right? Like, obviously, the technical stuff isn't simple by any means, but it's generally straightforward. Like, that if you want to implement something, you've got to do steps X, Y, and Z, unless it's something that is relatively new or never been done before. But then when you get to game design, that's where it kind of you get the the technology, the differentiation between a game that the technology is great but the gameplay sucks or whatever, right? And we don't want the game not to be fun but to look good. We want it kind of to have that balance of both things. And they were on Discord yesterday or today. The fine folks there were chatting about how hard game design is, and I totally agree. Game design is really, there are a lot of books about it and a lot of people who are excellent at it, and I don't know that it's really as well understood as some of these other technical aspects of making games. Alright, so okay, good. So you can see we're getting the patterns that we're looking for, but the attribute updates are all screwed up. It's interesting, and it even looks like it's updating halfway into the attribute memory the wrong way. Now I'm seeing these weird glitches, and I don't know if it's my computer being weird or the emulator having an issue. Or yeah, did you see? I don't know if you saw that little jump. That was strange. I want to see if we can see that a little bit better if we slow down the emulator. So it looks Wow, well, I don't know what that is. That's weird. But then you can see that we got shifted by 3 meta tiles, it looks like. But the good news is it looks like what's happening is it looks like the updates are maybe off by a row, or is that a couple rows? That's a couple rows. It's off by half a meta tile, because you can see that this attribute updated with the proper palette for this row of meta tiles, but not this row, and it did it across both. So if we go to the name table viewer, we look at that for a second. Is that the bottom of the screen? It's pretty close. So like that's the bottom. Oh, right, because our status bar is actually being drawn at the top here. So that's definitely the bottom. And I could see where the update of the attribute would be wrong potentially, because that one's tricky. That one requires updating split across the bottom of the attributes and the bottom of one set of attributes and the top of another set of attributes. Because if you look at the memory, the last 8 nibbles that represent the bottom of what would be the last meta tile don't actually have a value. I'm not doing a great job of explaining that, but if we go back to Wikipedia, if you go back to the attribute table, if you remember, this last row is only half a meta tile. That's what I was trying to explain. So we need to update just the lower nibble of this row, not the upper nibble, because it doesn't actually do anything. And I know I've used this before, but the term before, but if you've never heard of it, the nibble is just 4 bits. All right, so guess the question is, where is the problem? Because we're good when we start out, and then that's wrong. So it updated this incorrectly already. And when we start, I forget, are we updating? Yeah, we're updating from the bottom. Okay, so when we hit the next row of meta tiles, then it's updating the attributes wrong. And so why is it updating the attributes wrong? Is it because it's updating the top left and not the, I'm sorry, the upper nibble and not the bottom one? This is okay. It's actually, so maybe it's the row of attributes before that. Let's take a look at this. So when we start, I wonder if what's happening is, let me go back and look at the load level. I wonder if it's because we're starting at the bottom. It's getting, the code is not right. So it's in split mode. Well, no, okay, it's at the bottom of the attribute memory. I don't actually think we need attribute counter for anything anymore. We weren't really using it for anything, so let's get rid of that. Attribute buffer. Okay, so let's see. If we're splitting, then we're taking the attribute value, which is populated already fully across the byte, and we're grabbing just the lower nibble of it. And then we're storing that into temp2, and then we're loading the attribute index, and we're grabbing, we're grabbing that, and we're anding F to remove the lower nibble value that's there, and then we're doing an OR against this attribute value and what's in temp2. So let's add a little comment here. Do an OR against the attribute value that was stored in temp2. And then we're going to store A into attribute buffer offset X. And then we're going to transfer X to A and set the carry and subtract 8. And the reason we're doing that is because we need to update the row before the next attribute set. I wonder. So it looks like maybe the issue is not with the first meta tile row, because that actually looks okay. It looks almost like it's the second meta tile row we load, where as soon as we hit that point, we update the attributes, but we're doing it on the wrong row of attributes. That's what it seems like. So let me think about that. Why would that be? So after we're done, we need to set up the attributes. So if we were in split mode, we would have incremented attribute index. Oh, wait a minute. Yeah. So attribute index. Actually, that might be the problem. So what? Oh, but we never store that. I was going to say the problem might be that we were manipulating attribute index incorrectly, but I forgot we don't actually store that. So we load it to the value that we're looking for in our buffer. And then we set the value at that location. Oh, do we not set the other value? Well, heck, that's no good. Oh, we are. Okay, sorry. So what we're doing here is we're checking if we wrapped our attribute index. Let's see. So we subtract 8, yeah, we branch if carry is set because we've wrapped, and we add 64 to it so we're at the right offset. Otherwise, we just transfer A to X. Now A has the new value of attribute index in it, which is fine. So we put that into X, which is our offset into the buffer, the new offset. We load A with temp2, which had just the lower nibble set. So now we want to shift that 4 times into the upper nibble. So we do that. Then we store that back into temp2 because we're going to use it later. And then we're going to load the attribute buffer value based on the new offset, which was 8 less than, so a row before the one we just looked at. We're going to get rid of the upper nibble and the attribute, which would correspond to the bottom attribute colors. And then we're going to OR temp2 onto that. And then we're going to store that back into attribute buffer X. And then we're going to increment attribute index, which is fine because we're ultimately traversing that one row. And then we're done with the attributes. And then what we need to do is we need to update the memory. Now what we're doing is we're not re-updating the attributes across the entire name table every time. We are just updating the row of attributes that should have been changed. So what we need to do is, okay, we make sure we're done with that row that we were processing for the meta tile, or the rows of the meta tile. And then we didn't, yeah, okay. And then let's see. We're modifying the screen memory variable here to get us to the next location that we need to be in, which is fine. We're doing a subtract to get to the next row location. We're handling all of that. So now that we're done with that, now we want to check to see if we have to load the attributes. So the way we know that we need to load the attributes is we check to see if we encountered a new meta tile row. We'd set this second bit up above that code at the top here. So if we do an AND on that second bit and we get a 0, which means this equal will be true, we're going to skip to modifying the attribute, skip modifying attribute index because we don't care about that. We're not doing anything. Otherwise, we're saying, okay, let's get the attribute index, and we are going to subtract 16. And the reason we're going to subtract 16 is why? Because if we are in a split mode, should we be subtracting 8? Oh, right. So we are subtracting 8. The problem is we have already previously incremented attribute index by 8. So now we're subtracting 16 so that we get a net of -8 from the original index that we came in with. All right. So then if the carry is set, we didn't wrap. Otherwise, we need to flip the, let's see. Okay, and then this was something that we changed in the last stream where we said, okay, we're going to load the attribute mode and we're going to do the flip of the mode bit to either 1 or 0, depending on what it currently is set at, and store it in temp2 because we need to know what the current mode is for configuring, for updating the last row before we switch from either split or not split updates. So we can't directly update it or it's going to mess the update up. And then we're going to clear carry, and then we're going to add 64 to that because we need to wrap back up to the top. But where this started to get messy, because we then potentially need to wrap back around, which all of this is kind of weird. So the idea was if this is the attribute table and we had updated this row of meta tiles, attribute index started on the left, it ended up on the right here. Actually, no, I'm sorry, it ended up on the next row, so we subtract 16 from it to get to the next row, except there is no next row there because it's gone off, so we've wrapped. So what it should do at that point is it should add 64, which would put us here. So if we let's do this in the 6502 simulator because it'll make it a little bit more real. So figure out what it's called, 65 Kildrick. Yeah, or Skildrick. So if we load A with 0, we'll load it with 8, and then we'll set the carry, and then we subtract carry with undo 16, and then we say branch carry set to skip add 64. And this is, then we're going to do clear carry, add carry 64. This is skip add 64 here. So what we would end up with is let's see, load A8 subtract C. That didn't work the way I expected it to. Branch carry set. Oh yeah, no, that's right. And then, oh no, dummy. It should be 40, not 10. And that gives us 38, which is the appropriate starting place for, it's 56, which is exactly where we want to be because it's the last row in the attribute table. The problem is that then before, so now what we want to do is we want to say, okay, that's the next row we need to update, but we still haven't updated the attribute data with the values that we were supposed to update it with. Maybe I should hold off on modifying attribute index that way until the end. I mean, it still could potentially, well, no. So, okay. So if I only subtract 8 from it, it won't wrap around because 8 is the proper number of columns. So let me think about this. So if we're in split mode, I should just use the pen instead of trying to draw a straight line with the mouse. Then we want to update just the lower nibbles here, right? So this is lower only for this one row, and then upper for that row. So basically what we could do is we could just do, if we just trying to think about how this would work. So if we're in, we're going to get an even 7. I feel like I'm overcomplicating this. If we return back to the position that we started at for attribute index, if we're not splitting, then if you remember, it's actually really simple, right? We load the attribute index into A. Where is this? So if we're not splitting, it's really simple, because what we're doing is we're just essentially writing out the 8 bytes from our attribute buffer right into this 2007, and we're counting down. Where it becomes more tricky is if we are splitting, but I don't feel like I feel like I'm missing something here because of the way that this is kind of messing things up. So let me think about this. If we were in a mode where we were splitting, then there's just draw this whole thing out, right? So there's 1, 2, 3, 4, 5, 6, 7. Right, that gives us 4, 8. So there's the 8 attribute rows, and this 8th one really is just this half metatile row, right? It's not a full. That's not really a full. The bytes are there, but there's nothing displayed in that last 2 rows of this. If this were, 8 32-bit tall rows. So when we're splitting, we're updating here the lower bit and the upper lower nibble and upper nibble of this, and then we're doing lower nibble and upper nibble of this, and then lower nibble and upper nibble of this, and then lower nibble and upper nibble of that, and lower and upper and lower and upper and lower and upper, and then we do lower to update the bottom. But obviously doing upper on here doesn't do anything, so lower upper, lower upper, these up a little bit better in terms of like almost a swim lane kind of diagram. So lower, upper, oops, then lower, upper, then lower, upper, lower, upper, lower, upper, lower, upper. And then when we get to here, it's lower. And then do we need to do lower again? Because upper doesn't do anything, right? So this is lower and lower. And then once we get to that, then it's upper and lower, and upper and lower, and upper and lower. And now we're just doing the individual full rows. So if we have attribute index pointing to here, and we increment it to the end by 8, we should be updating upper and lower across the split like that. And then if we subtract 8, we're back at the beginning here, and then we need to go back 8 more for split, and we do 16 updates across those two. And then when we update the next one, we do the lower and the upper, and the same thing, 2 rows, lower, upper, and 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 2 rows. When we get to 0, and then we do lower, and then we wrap, and we have to do upper. Well, no, and then it's lower and lower if we're at 0. I'm confused about how to make this work. Or I'm not confused about how to make this work. I'm just trying to think of what's going to be the most efficient way to make this work, because that special case at the top is annoying, because we have to do something special when we are in split mode and we're at the 0 index. And then once we're done with that, then we split back out, we go out of split mode, and we just start updating the rows individually. And then we go back into split mode. I guess it can't be helped. So the question is, okay, when we're updating the attribute memory here, are we handling, I don't remember, are we handling the wrap properly when we subtract the 8? Branch carry skip, yeah, so we're clearing the carry and adding 64. So that would put us back at the top. But now, the only problem with that is that we, in that scenario, shouldn't be updating the lower attribute, or sorry, the upper attribute. We should be updating the lower attribute. So, I'm going to do this transfer A to X early here because I need A, and what I'm going to do is I'm going to load A with mode, and I'm going to add another bit 4, identify that we should take the lower nibble because we wrapped. And then what we need to do is, now that we have X, well, we had X and we have that bit set, we either see, load a compare, well, and with 4 branch of equal to modify lower nibble. And this will be this code modifies the upper nibble because we didn't wrap, and this is modify lower nibble. This is store attribute here. So basically what we're doing is we're jumping over, actually, sorry, this branch is wrong. This should be branch of not equal to modify lower nibble. So here we want to load A with temp 2. We don't want to do the ASL because we don't want to shift this. We just want to, again, modify the lower byte. So we're going to store, oh, so we don't even have to do that because it's already the value we want. So what we do want to do though is we want to load attribute buffer of X, and then we want to AND that like this to clear out the lower nibble, and then we want to do an aura. We want to do the OR here, or the attribute value in the lower nibble because we wrapped, and then now A has the value we want, so we're going to store it in the attribute. We're going to increment the attribute index and then jump to done with attributes. Of course, 1341. Next meta tile branch if equal to, so we have too much code in between. Branch if equal to no more meta tiles. Oh, I was like, why is that so slow? Because the emulator is slow. All right, let's see if there's any change in behavior or if we're seeing, no, we're still seeing some consistent weirdness. And I don't know that this is wrong. I think we're just going to have to step through this because I feel like I'm just missing something with the way that this is all working. So let's go into the hex editor. And as usual, we're just going to move the thing we're kind of interested in to the beginning so it's easy to identify in the hex editor. All right, so the first 64 bytes now are our in-memory representation of the attribute table. And so what we want to do is we want to wait for an update to that as we load in the next meta tile. So nothing happened there. Oh, so that got updated. Let's do this. Uh, 64 is here, so let's 0, 1, 2. Oh, it actually, I never noticed that it had the address up there. Let's add a breakpoint for if this is written. Let's remove a hair or something. Let's remove that breakpoint. So we hit a breakpoint on, we're updating the attribute table. All right. Sorry, that's annoying. Something is stuck. So let's look at where we are here. So we're doing this looks like okay. So this is this code here. Transfer X to A. We're going to subtract 8 because we're in split mode, so we need to go to the previous row. The carry is set, so we're going to skip over the wrap check. So now we're transferring A back to X, and we're checking to see if oh, that's not going to work. That's not going to work there. We need to do it there. We'll just do this. Modify lower, just jump right to modify lower nibble. Because we wrapped. Yeah, that looks right. All right, so transfer X to A, set the carry, subtract. Branch of carry is set because we didn't wrap. Transfer A to X. Load A, temp 2. Do our shift. Store it. So let's see. If we look at the hex editor, we just stored in 53. Why in 53? Oh, is that temp 2? Oh yeah, that's temp 2. Okay. So then we're going to load the attribute value. We're going to end it. Then we're going to OR the value in temp 2. And then we're going to jump to the store of the attribute. And we're going to write that value. And we're going to increment. Jump, and we're going to keep doing that, and that row is essentially going to be zeroed, so there's really not much interesting going on there. Maybe we need to do one for every row of the attribute memory here. Nope. So it made a change, but we didn't get a breakpoint. Got a breakpoint there on a write to 28. Let's see, 38, 30, 28, 20. Why? That's interesting. Add write. Add write. I'm just going to add breakpoints to all of these locations where we would have an update for our attribute memory. So let's oh, that's why this one didn't trigger, because this is for execute instead of write. Okay, run. All right, so we do that. And obviously we're updating our attributes so we can see it's triggering down the row there for all of the attributes in the array. So this is our first update to that row, and then to that one, and then we should get to 30 again. Okay, good. So now it's updating starting here, which is the next row. So that all looks good. And what we're doing, let's see. So it's storing the first update. Let's see. Load X with attribute index, load attribute buffer X, and then it's doing the store AX. Okay, this is the F0 and then the aura, and then increment of and F0 aura STA increment. Am I looking at the wrong spot? All of that looks right up until that point. Load X. Maybe it's not. Maybe it's not because I don't see this load A row mem here. Is it? That's not it there, right? Well, maybe. It's modifying 30 on this store. X is 30, and it had just loaded that. Is it lower here? Is it this part that I'm looking at? OF or A jump load A X and F0. Okay, it is. Why is that? Because that should have done it. That's strange. That should have triggered it at this location when we did the store. Oh, this is load. At this location when it did the store here, which is up over here. So we've already passed that. Why is that? Let's reset things here. Can I reorder these? No. Okay. Well. All right. So start. That's loading the level. All right, so we hit the load of the attribute, and that should be all pretty straightforward. We should hit 38 and then 30, and we do. Okay, and then we hit this address again. Why? Oh, because we're going to keep doing that. We're going to do that for every attribute that we have to update. Oh, wait a minute. No. Okay, no. That should be fine. I was going to say we're doing it too many times, but that's actually okay. So now we're at the next meta tile. All right, so now we're updating wait, why is it doing that update without hitting this execution? Store A 0 30. And let's see, E7. How would we have gotten there? So EO store A0 store attribute load X. So it's a store and then an increment. So that's our 4 ASLs here. Then store a temp2 load a attribute buffer X and 0F or a temp2 jump store attribute load a X and F0 or a temp2 store a attribute buffer X increment that doesn't seem right. Why is that incrementing? Where? Oh, okay, I'm looking at the wrong place. Yes, okay, so that's incrementing attribute index. Then we're doing jump done with attributes. Then this is set attribute no split. Okay, this is the problem. This is doing a set attribute no split, but it should continue to be split. So why is it setting the wrong mode? Let's see. So we're at load a attribute subtract carry. branch carry set load a attribute mode EOR. Okay, so this would be our check here for if we split. If we switch out of split, I would say. Let's reset this. So that might be why we're getting this problem, is because what's happening is we are potentially getting the wrong condition set here. So I actually want, no, that's okay. So let's run this. Updating the attribute memory. Okay, so now we're running through. Okay, so that's the E7CA, which is loading the attribute memory for the split, because the next instruction is our AND 0F, store A, LDX, LDA, and F0, or okay, so this is all right. So that's our split code. And we're updating that row, and then we're updating that row. And now we're still in our split code. And we're going through and updating until Y has passed 16, which is the end of our meta tile update for the row. And now we hit an update of 30, E8F1. Store A, where? It's very odd. We're at store A 00x 30 increment Y. How did it get to that already? I'm confused. Store A 00x. Increment Y, compare Y. It shouldn't be at that point yet, though. That's, yeah, that's set attribute no split. So I don't understand. Oh, the code moved, so it's not triggering there correctly, but that's the code that it so bizarre. Branch. Oh no, the code didn't move. It's just, what happened? Why is it calling no split mode? Branch carry set. Load A, subtract carry, branch carry set. So E7CA is the split mode update. And then we're going 38, 30, and then we're just calling that a bunch of times, which is fine. Okay, so that's the branch carry set. Carry is set, so it shouldn't be changing the mode to non-split update. where the hell did that code go? I was just looking at it. Here. Branch carry set attribute did not wrap. Store a attribute index. Okay. So if I step over, it should now store A, and it did. And then it's going to load A with the mode. And it's going to do an and it's going to compare it, and it's going to branch if not equal to load attribute address. Oh, that should be load split attribute address, shouldn't it? Branch if equal. Right, because if we get 0, then it's the non-split mode. So, all right, let's build that and step through this again. Okay, so step over that. All right, so we're storing, we're loading, we're doing an and compare it, and we branch if it's equal. Wait, what the hell did I just do? Oh, because I did, that's why. I had that right. Sorry. I'm so used to using the and checking for the 0 case that when I did the compare, I forgot that I did that a different way. I mean, I could do that the same way to be consistent. I can do an and 1 and then branch if equal to. It's probably faster. Save us a cycle or two over the loop. All right. Let's try this again. And let's see what's going on. So step over that. I wish it would highlight. I wish it would highlight the line and not just have that little caret there or the greater than, because it makes it a little bit tough to follow. So and a branch if equal, which it's not, so now it's going to load the split address, so it's loading attr index, which has 30, and then it's going to do a bit because we're going to update the address, so load a 23 stored in 2006, transfer x to a, clear carry, add carry to C0, and then we're going to store that because that's the attribute location that we need to store the value in. Right, 2, 3, yeah, store that. And then we're going to load y with 16, and then we're going to jump, and we're going to update the location 1 row at, well, yeah, we're going to do it 1 row at a time. And let me think about that for a second. We took 23C0 and we added, so we had F0 in the end, minus F0 minus C0, it's 30. Okay, yeah, that's right, because we want to modify that row and then the following row, which is starting at 38. So that's okay. So now we're going to do 16 updates, right? So we're going to store 2007 once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we've done that update here, right? So we had X grabbing the value from attribute buffer, which had these values, this whole row of 0. We stored it in 2007 and incremented. We decremented Y so that we did 16 updates. And then we load A with temp2, which has the new attribute mode. And temp2 has 3 in it. Step over. So that's good because that's still split mode. Oh. No, that's the problem. So did we clobber temp2 somewhere along the way? No, you know what it is? I did not. So we got to store it no matter what we do. Load A. We got to store it here no matter what we do. Hold on a second. The reason we got to do this is because if we don't do the branch, we still need temp2 to have the value of attribute mode in it. That's why it's switching out of the split mode like that incorrectly. So that makes sense. Now the question is that going to fix the problem that we're seeing? Or is that just one of many? So that updated 30, and then we should see an update for 28. That's good. So far, that's looking better because the split mode is actually operating the way that it's supposed to. Although, you can see it didn't quite work right. There's still something that's not 100% right. So let's take a look. Let me just take all of these out here. Let's look at the memory. Can I squash that down? Just to get 8. I can. Cool. So this is the 1, 2, 3, 4. Yeah, so that's the first row of attributes. That's the second row of attributes. That's the third row of attributes. Let's take a look at the name table too. So, well, the cool thing, or I mean, it's not great, but what we can see is that it does seem to be reflecting what we're seeing on the screen, I guess. To some extent. That's a little strange. Why? That's interesting that it's not exactly 100% right. Damn it. Is the debugger running? Is that what it's doing? Looks like we might be running into a timing issue on the update, but I'll deal with that later. This looks better. This looks like we're actually getting This looks like we're getting the attribute updates mostly right. Seems like the last one is not getting updated properly. Also, that's wrong, and I don't know if you saw this row. That's no good. All right, so there's obviously still some sort of issue with the way it's handling the updates. It's weird that that's happening sort of outside the bounds of no, I guess maybe it isn't. It's hard to tell if it's happening. It looks like it's happening when the row update occurs, that little jump. And then that's just totally wrong. That issue with this attribute not being updated right, I wonder if that's just we're not counting down enough because of the way that I'm doing the compare with the Y. Let's see. Just a simple off by one, maybe. Nope, it's just wrong. Okay. Seems like it's really did that actually just not do anything? It's still having. I would have thought that it would have had sort of different behavior if that was. See, watching this. Yeah, so that weird jumping is probably related to just timing, code taking too long here. It's getting ugly here. Oh. Let's see. No, that would still. I was thinking that maybe if we got to the point where we're at the end, it wouldn't wrap, but it would still. Maybe what I need to do is I don't know. I'm trying to think of what's the best way to troubleshoot this, because it's a little hard to tell what the exact issue is. Looking at the way that update to the attributes over here happened, if we go A0 binary, that's palette 2, and that is, I believe, the right palette for, yeah, 0, 1, 2, so that's the right palette for this portion. But what I don't understand is why What I don't understand is why this is acting so strangely. Oh, is this not? It's not doing what I wanted it to do. No wonder it didn't look right. I thought I was contracting this down and getting a representation that looks like the actual memory, but that's not what's happening. It'd be nice if I could do that. Doesn't look like I can. Yeah, it would be cool if there was a way to shrink down the number of bytes that it shows so that we could get the appropriate layout. But anyway, so what I don't quite get is if we look at the name table, you can see that, where's tiled? Let me reset this for a second here. Go back to the bottom of the screen. We have that, and then we have a third row of gradient tiles, and then we're supposed to get, what, just one row of the blue. And then another row of gradient. Now, ignoring the visual glitching that we're getting for a second, because that glitching is related to the timing, like I said. Do I care? Yeah, so we've loaded this row in. This attribute is wrong. This attribute is wrong. These are not necessarily wrong if they don't look right at the moment, because they're not the row that we're actively reloading out of view. So let's see. So realistically, what we're showing is that this last column is wrong. The question is, does that correspond to what we're seeing in the memory? 0, 0. Okay, that's all A. Yeah, and then we get another row of 0. And then, right? Yeah, and then we get another row of 0. And then we have a row of A0. And then a row of 0A. Let me see something. This is I'm just trying to match up what I'm seeing with what's in this memory. So this is all all palette 0. This is all palette 0. This is currently set to all palette 3 across the whole row. This is set to all palette 0. This is set to a split between palette 3 and palette 0. But the behavior of that is odd because that doesn't match with what I actually see here. If this were working the way, if this memory represented what was here properly, it would be slightly more varied. So if we go into the PPU memory and we go to go to address 23C0, obviously we will see what's actually in memory, which is there a way to open up another hex editor? No. So what we're seeing here so this should be 16. So this is the attributes for the screen. This is what's actually in the PPU according to the hex editor. And then what we think is there based on what we have in our memory is this. Did I miss a row? I missed a row. Thought it was going to be that stream from the other night all over again, where I'm messing up all my character manipulation. Okay, so it seems like we messed up something somewhere in the way that we're doing the updates because... Well, no, okay, that makes sense. That makes sense why it doesn't look right, because we're actually not... We're actually not updating it 100% correctly. So even though the memory looks like it should be okay, the PPU update is not. So I think that might be because our NMI is taking too long. If we ignore... Let's ignore this stuff. Where's my loop for read by? Yeah, get rid of this for a second. Is that not how you comment? Oh, it's dash dash. Okay, so let's see. Well, slow down there, Paco. All right. Yeah, oh, that's way too long. So it was going over 2300 when it does the attribute update. Okay, so that's why we're getting that bizarre flicker. Well, so how do we make that faster so that that's not a problem anymore? Besides not have so much stupid logic in here. let me see something here. If we, curious to see, just comment this out. So we always skip the modify of the, let's see what the timing looks like on the NMI. Just processing, it's still pretty bad. That was over 2,000. We don't want to get over 2,300 because, whoa. That was, oh, I see. I know why. Because that's probably the attribute index is getting too big and it's overrunning 64. So let me look at this for a second here. So one of the things that we had done in another bit of code was we had said, okay, we can bound things to a power of 2 by using a bitwise AND. So 64 is certainly a power of 2. The question I guess I had was, if we were at 8 and we subtract 16, we get F8 in hex, which is 248. And so what we wanted to do, or what I was doing, was I was adding 40 to that. Well, that's not exactly right. So because of the way the calculator is working. So if I then add 64, we get 38. The other option we can do is we can just say, no matter what we do, we take the value minus the 16, right? So that would give us F8. And then we can AND it with, what is the value? It would be 63. And that gives us 38 also. So we don't even have to, so that would work. We wouldn't even have to do a check if a carry occurred. We just keep bounding it. But the problem is that we do need to know if it wrapped, because then we have to switch. Could we use the carry bit to change the mode? I don't know. Let's see if we set the well, no, that wouldn't work. All right. So we can definitely do this. We can get rid of this part here. Well, not exactly, definitely. Because this is the problem with this is that if we wrap, we have to modify the lower nibble of the top, or of the bottommost row, in order to make that wrap happen properly. I mean, we could go back to what I was saying originally, which is we could make the attribute tool figure out what the appropriate, well, it wouldn't know the appropriate location in the attribute memory to update, though. Could set the appropriate, we could save some time by getting the value already pre-configured for. But even that's still not really saving us much. The real issue is all of this sort of complex logic we're doing here to update the attribute buffer properly. Let's do this. Let's forget about that special case for a second. So we're gonna end this with 3f. So regardless of what happens when we do the subtract, it's gonna be bounded to 64. So I know this isn't exactly right, but that's okay. Let's skip that special case here. It might end up being that we see a better path through this by simplifying it a little bit. So whatever happens, we're wrapping to 64, and then we're transferring a to x, and then we're going to load temp2 back in, and then we're going to shift it. Do we need to store it here? Why don't we do this? Oops, not delete the whole line. Can we do that? Oh, that's the problem, is that the value in the attribute buffer can't modify y. X has a value that we need. So we do our shifts, and then we store it, and then we just trying to be do a little less juggling with the values here, but wait a minute. Why was that an add with carry? Is that just Sublime Text helping me out? Yeah, so that's a load. Load temp shift store load a. Store it back. Let me see here. Is there anything that's going to help us with the? No, let's see. Or a. Yeah, I mean, I know. Oh, wait a minute. Hold on. Well, is that any better? Is load A with. If I load A with a static, a constant, that's two cycles, and then actually, no, that's okay. I load A with a static that's 2 cycles, and then so I'm thinking I'll load it with OF and then do an AND here. That's going to give me 4 cycles. That's 6 cycles versus 2 cycles for immediate plus load A. I think it's going to be the same. It's actually a little bit, yeah, it's the same. So that's not really saving me anything. It just kind of sucks that I have to do this whole elaborate nonsense to get the bits where I want them. Store that. Okay, so then we increment the attribute index, and then we're done with those attributes. Increment, compare, yeah, branch of equal, otherwise jump to next meta tile. I mean, so that's a little bit simpler than it was before because we're not dealing with the nonsense of the split lower nibble update, but obviously that's not going to update it properly. Let's see here. Let's see how this looks with this change. Yeah, it's still too long. That was still 2,300 cycles. And I guess it's not doing this until we load a new meta tile, so it's not like it's doing this every update. It's just when we get to the next row of meta tiles, it's got to load this. So there's some extra work where it's comparing this to determine if it needs to go and do the update again. It does not all the time. And then we check if it's split or no split mode. Maybe it's better. Let's see. So what we're doing is we're doing a load A, we're anding it, and we're storing it into temp here. And then what I was doing was I was loading temp and doing the shift. Maybe it's better to do this. And then, because then we don't need those repeated shifts. I mean, that's not going to save us a huge number of cycles, but I'm just trying to think of kind of everything we can here. At least from a simplistic point of view. Still too high. That was 2,300. 13, 23. So it's not as bad as it was. We're just barely making it in under the clock for the NMI. It looks like it's updating the attributes correctly though, so that's exciting because that all looks right. Let's speed that up a little bit. So in simplifying that, looks like we fixed at least some of the problem. Obviously, it's still not working correctly because then it glitches out like that, probably because the attribute index gets too high and then it starts modifying state. All right, so I'm less unhappy about that. Is there anything we can do to simplify this further? Well, let's see. Load X attribute index. Do we have to do this for every 4? Yes, because right now we're using X for the update to the meta tiles, so we do have to do that. Okay. So we're ending it this way, and then we're ORing temp2, then we're storing an attribute buffer, we're subtracting our 8, making sure we wrap it, we're transferring A to X, then we're loading the attribute again, and then we're ANDing F0, we're storing that in temp2, we're doing our if there was some way we could there's some way to, I don't know that there's a way we can erase the bits that we need to without loading it and doing the AND before we do our OR. I mean, I think you can do an LSR. You can do an LSR in the memory, but we're talking about a lot of cycles there. It's 6 cycles per call, or 7 if we're using the X. So that's not going to work because that's going to be even more inefficient. It's better to load it into A. And this is just going to do an EOR on. Those are just acting on the accumulator. Not sure. We don't really gain anything by doing this, right? I mean, basically we're same number of instructions. I believe it's basically the same number of cycles. Hmm. I mean, the split mode is just kind of gnarly. The only other way I can think of that we could do it relates to how the data is laid out in the file, where right now we're alternating between metatile attribute and we could do, you know, row of metatile eight metatiles, 8 attributes, so that we're only ever dealing with one, versus right now what we're doing is we're basically kind of handling one set of updates at a time. So if we load up 4 tiles and this happens to be a new metatile, then what we're doing is for that one tile we're going into the attribute memory and we're updating those 2 rows in the bytes, right? Which doesn't sound like a lot, but you're doing it 8 times. We know, let's see, it's not doing it any more times than that, right? It's only saying, okay, let's make sure that we're not accidentally doing it more times than that. Yeah, so before we get started, we're making sure that we're not updating the attributes unless we hit a new metatile row, and then if we hit the new metatile row, if we hit the new metatile row, then we have to load in the attribute one at a time. Does and modify carry? No, it doesn't. Or does not also. So we don't know what this is going to be. Just trying to think. Let's see, subtract with carry. And we're doing that with an immediate. That's 2 cycles. So that's 2 cycles. That's not that big a deal. I mean, we could. That's going to be a little bit faster, I think, right? Because load A with the, that could be 5+ cycles. So it's 5 cycles versus, so that's 10 cycles versus a 5 cycle operation and then a store A. Store A 3 cycles and then where the hell is it in here? 3 cycles, 6 cycles. Bleh, it's not even that. That's not even better, is it? That's actually more cycles, potentially. Okay, so that's not going to help us. Well, you know what? Let's see why the code for when we switch out of the split mode causes the game to crash. I mean, I know why in general it's doing it. It's because we're probably overrunning the memory, but let's confirm that that's what's happening is we get to the top of the screen and then it causes the game to crash. Yep. There it was. Okay. That was pretty cool. So hitting start to go to try and activate pause caused it to kind of reset the game a little bit. All right, so this is skip row load. So we're checking to see if we actually loaded a new meta tile row, and if we did, then 2 would be set. Otherwise, we're skipping the modify the attribute. So let's load the mode, store it in temp2, load the index, subtract carry. Then let's end with 3F so that we don't have to do an add later on. Now we can check if the carry is set. We know that it's going to be the right value no matter what, so we don't have to do that. Branch carry set, and doesn't modify carry, so carry will continue to be set. So load a attribute mode EOR, and then store that into temp2. Actually, can I just do, I guess it doesn't matter, load a EOR temp2 and then store it, or EOR attribute mode. I don't know if that's more clear or not, but all right, so now we're going to store the attribute index with whatever is in A. And then we're going to look at the mode again. And see if we have to split or not. Actually, I wonder if we could do that might work. What is it? I want to rotate left. Carry shifted onto bit 0. So if the carry is set, maybe what we'll do is we'll reverse. If the carry is set, then we didn't wrap. If I rotate that, no, because that doesn't, all right, never mind, that's not going to work. Never mind. They're not correlated. All right. So loading the attribute mode, ending with that. If it's this, if it's equal, meaning that we had a 0, then we're just purely loading the attribute index and processing the row directly. So, all right, so in this case, we're not in split mode. So let's see. So at that point, attribute index had been subtracted. We had subtracted 16 from it. Okay, so then this can go away, and this can just be and 3f, right? Because if what we were doing here is we were adding to it and seeing if we wrapped around. If we didn't do anything. Otherwise, we were wrapping it ourselves. We can just do and 3f. That'll wrap it correctly. And then we want to transfer that to x. And we want to set the address up properly. So that's transfer a to x. Yep. So then we do bit on 2002 to set up the addresses. So we load a with 23. Transfer x to a. And we add C0. Well, you know what? Why don't we do that here? This way we don't have to transfer it. Yeah, so that's now in X, and then we're just going to transfer X to A and store it and load that we're doing 8. Okay. So let's see how that goes when we get to this. Well, didn't crash this time, so that's good. But it's still not right. That's interesting. So it looks like the harder case of the split mode is actually working more correctly than the non-split mode. Isn't that how it always is? All right, let's take a look here. So we're setting the attribute with no split. We load the attribute, we load the attribute index, and we store it, and then we increment. And then I guess we need to do that. Well, to make sure that we don't overflow our buffer. And then looks like it's only half correct on those updates. All right, so now the problem is that looks like we're not updating the attribute memory correctly for the case where we're not splitting. And the reason for that would be what? What is the reason for that? Because after we get to the bottom row, and we subtract 8, We say, okay, now we're splitting. F8 is that, so you add 6, well, you get 56, but is that the right row? No, the right row should be 30 for the, so that I think is part of the problem, is we're not actually getting the right index when we're out of split mode. So let's see. So the other thing we need to do is load a 30. Oh, well. See, that's the other thing, is this whole nonsense of the fact that we're determining it here. Maybe I shouldn't be doing this here. Maybe I should be doing it at the end, and then we can... And then we can deal with... I think that maybe makes more sense. Let me comment this out for a second here. So let's just look at the mode, if we're at split or not. So when we're in the situation that we've split, or that we're doing a split, our index is where? Our index is on the wrong line, because we've incremented by 8, and we need to subtract 16. And so our index is not going to be right coming into here. What we should be doing is subtract that and this. Well, there's a whole other issue that I just realized. Well, let's handle this for a second. Transfer A to X. So that gives us our X now. And then we have our location that we're writing to, and then this should be 16. And then transfer A to X, transfer X to A, and 3F transfer A to X, because if we wrap, we have to wrap, right? We want to bound that to 64. Okay. And then, all right, so that's that. And then if we're not, yeah, so in this case, we're loading that. And then when we're done, we say, okay, so now let's let's deal with modifying attribute index. So load A, attribute index, subtract C, or well, clear carry, subtract with carry, 16, and that branch of carry is set to skip mode, just skip modify attr index. Otherwise, we have a mode swap, right? So we're going to load A with 1. We're going to Eeyore attr mode, and we're going to store it. And the only question is attr index going to be correct. In the case of the split mode, yes. Because we've got 56 minus 16. So now we're going to get minus 8. Which is going to wrap around to 64 minus 8, which is 56. Which is wrong for the non-split mode. I wish there was a... I don't know if I'm just missing it or if it's just literally this obtuse to handle, because it's not an even 64 all the way around. Branch if equal, so if the attr mode is now non-split mode, so branch if not equal to store attr mode. Otherwise, what I want to do is I want to load store attr mode and then load A with 3. So 30 is the address we need for the non-split mode, and then store that into attr index, and then jump, skip, modify attr. This code is not exactly what I was hoping for here. That's totally not working right now. Now we're just modifying the name table. All right, so that's great. Load the attribute mode branch if equal to that one. Otherwise, oh, are we still doing the whole temp2 thing here? Where it's using that for the attr. That can go away, right? That was leftover logic from before. I don't know if that's going to fix the problem that we were seeing, but shouldn't have been doing that. No, that just broke it completely. Still. So load the attribute mode and then branch. Okay, so we're taking our attribute index. So we were doing the same thing. We were setting the carry, subtracting, doing an AND to make it wrap. And then we're saying, okay, we're transferring that to X because that's our offset for this. Oh, that's part of the problem, is that when X wraps, if X wraps, oh, that's so maddening. So if X wraps, we have to change the address? No. Oh my lord. Is it more worthwhile to just see if we can get the attribute table loaded in full instead of all of this nonsense for dealing with how to update just one row? I mean, this is becoming ridiculous. It might be. I doubt it, but for argument's sake, and for the sake of, I don't want to find this out after another hour of testing stuff. Let's just for argument's sake say that we're going to start at the beginning of the buffer and load attributes, update. We're going to bit 2002, and then we're going to load a 2.3 and store that in 2006, and then C0 and store that in 2006 also. And we're going to load 0 into there, and then we're going to do load a attribute buffer X store a 2007, and you know what, we don't even have to use we do need to use X, but instead of looping this, let's just go for broke and do a repeat here. We'll just unroll this whole loop. We know it's only 64 bytes every time, but we still need to make this 0. 1352. Of course, that made us out of range here, but that's okay. Let's see how that fares. So basically, I'm taking a lazy approach here and just updating the attribute table every time. I don't see how that could possibly work. The other problem is the attribute index is gotta make it wrap. If it doesn't wrap, it's going to overwrite stuff. So let's... Looks like it's pretty bad. Well, that's actually not as bad as I thought it was going to be. That's, I mean, it's 2,600 cycles, which is still a lot, but it's not nearly as bad as I thought it was going to be. And it's certainly a lot easier. Interesting. Let's take a look at this again, because I want to see how the updates look in terms of the palette update. Let me go back and turn that off, or add the cropping back. So that's looks like it's not properly interesting. Why? Oh, maybe because it's running out of cycles to do the update of the attribute memory at the end. That could be. Need to make sure that that's bounded the next time we read it in, so we're not updating our buffer incorrect out of bounds. All right, so let's see. How can we tighten this up so that we can make this work within the time allotted? Well, let's do this. I'm curious to see if I comment this out, if it makes it. Like, is this the determining factor, or is it the 64 updates? Because if it doesn't work with the 64 updates, then there's no point in trying to optimize that code, right? Because then we know we'll never make it. The 64 updates are pretty straightforward. Name table. So that's actually, where's my Lua? I mean, it's not pretty. It's still 2,000 cycles, but that still leaves us some leeway if we can optimize the code that's actually updating the attribute memory. So what if we trying to think how we can do this. Let's see here for a second. Is there anything we can do to make that repeat process a little bit faster? I mean, there's hardly any code here. Let me see. So we're doing a load A. That's 4 cycles plus a store. That's another 4 cycles, and then incrementing X. And that's 2 cycles, so that's 10 cycles, so that's 640 cycles to do this. The funny thing seems to be that that's faster than what I was doing before. I mean, you know, all of this is a learning process. I've never done this before, so trying to figure out what's going to be the most efficient way. That whole split update between the top and the bottom is a real pisser, because it's an annoying edge case that we have to be able to handle, or the attributes are going to be wrong. I mean, the only thing I can think of that would save us having to calculate this is if we pre-calculate it in the attributes, in the attribute data that's written out by the asset tool. And so the thing with that is that then the asset tool has to know, okay, so we're going to start in split mode, so here's your index, and then here's your 2 rows of attributes that you're going to write, and then the next row of metatile data, same thing. And it would only have to do that at the time that the metatile data is written, or a new row of metatiles. Well, it would do that every time because it would know. And so because it's only dealing with the metatiles in the asset tool. So it would write out, let's think about that. So it would write out 7, it would write out 8 rows of split, and then 7 rows of not split, and then 8 rows of split, and then 7 rows of not split. And it could tell us what the offsets would be, both for where to write it in our local attribute. Well, no, not even, we wouldn't need the attribute memory anymore. We would have that stored in the level file. The problem is then you're talking about for each screen of the level, you need to store 64 bytes. So 600. So you could get easily a K of just that information, and we don't really have all that much space available to us. Right? What is that? That's 8K. Wrong number system. That's 8K. That's 8K for everything in that ROM bank. What does level 1 look like right now? So level 1 is already 2K basically. I mean, it's not exactly 2K. That's almost probably too big. It's 1600 bytes. Sorry, I'm just thinking through what our options are. I mean, part of what's taking up that space is we're storing the attribute information in line in the rows. Technically, we don't have to do that. We could look up that information. It can be tied to the meta tile. And just like we're looking up information about the rows associated with those meta tiles and reusing that, we could look up the attribute, but we're still then running into the problem of what we're running into right now, which is that we've got to calculate all of that. Maybe we don't do an update of the entire screen. Maybe we just do an update of half the screen at a time. Let's see what that looks like. I mean, it should half the number of cycles required, and we just have to determine which half of the screen we're updating at any given time. Again, if that makes the logic simpler and uses less cycles overall, compared to trying to be smart about it and doing all of this updating that ends up being pretty slow. Yeah, so like if we could narrow it down to just updating half the screen all the time, either the top half or the bottom half, depending on what meta tile data we're loading, that would work. And that would be pretty easy to implement. It wouldn't require a lot of crazy logic. So maybe that's what we'll do for next stream here. Hey Vashtarek, sorry I didn't say hi earlier. Busar 3S, this is assembly language. This is 6502 assembly for the NES, the original Nintendo. right, so while we're not in a working state with this, it's definitely better. We're, I think, in a better place because we understand the problem better. Because now we understand that trying to just update the single row is actually more complicated in terms of updating the PPU, because the PPU, it requires that we set up the address we're writing to here in this 2006 address in the register, and then trying to handle that properly with the split is, it's kind of ridiculous, because basically what it means is that then we have to update two separate parts of the attribute memory, which means we have to load that into 2006, which means now we've got to do all of that stuff again, in addition to figuring out where we're updating the attributes in memory and then loading the attributes. And it seems like the process of figuring that out takes more cycles than just updating half the attribute buffer, just writing out those 32 bytes arbitrarily, depending on, you know, even the 64 byte update was working reasonably well, considering what a dumb approach that is, just kind of dumping everything. You know, that updates properly, even though it's kind of slow. So if we could use that approach, then why not? We still got to figure out what we can do to make this a little bit more efficient, but I'm not sure I have a good plan of how to do that at the moment. I feel like it's I don't know. I really don't. I'm not even sure exactly where, like, if I just so just never mind that, you know, the colors are wrong in the updates that it's doing, but that jumping that it's doing is the fact that it's taking too long to complete in the NMI. So then, like I said before, then, like, okay, so then what's the best thing we can do to make this be less code? And right now the problem is that we're executing this for each meta tile. I'm wondering if let me think about this for another minute here before I wrap this up. Like, if we get rid of, let's get rid of all the logic for split mode here for a second. Well, we can't get rid of all of it. Let's get rid of the logic that doesn't do the incrementing. Oops. Let's get rid of that. So basically we're just going to increment it for split mode, but then for non-split mode we'll do what it's supposed to do. I mean, that's working fairly well. I mean, it's not doing the little flicker here, so let's see. 2200 cycles. Really? 2200 cycles? Is this running more frequently than... It's just doing... Oh, I have this doing 64. Let me reload this for a second because I want to see what it would do if we could only update half the attribute memory at a time. $1900. It's odd. It's odd to me that that's... Load at, let's see, so this is, what does it look like when we're, yeah, 1900. So if I get rid of this for a second, just want to look at what the base NMI looks like roughly. All right, so there's a little bit of extra cycle time when there's like an extra 100 cycles when we have to load a new meta tile row, because it's 1400 without it, and then we hit another meta tile row. Well, it's about 200 cycles. So 1600 cycles is what it's taking us to do the tile load stuff. And then, oh, we're not even doing this. Load A. Well, we can do that here. Okay, so that's with the 32, so that adds about 300 cycles. Yeah, and that makes sense because this is about, so this takes about 10 cycles per iteration. So that makes sense that we're seeing about 300 more cycles now to copy the attribute memory. Yeah, the big problem is that the split memory mode requires doing all this bit manipulation. So I don't need to do this anymore because I know coming out of it, it will already have been bounded properly on the previous loop. So let's see. Load that, transfer A to X. And this is going to load the whole byte of that value. And then that's going to clear out that lower nibble. And we're going to do the OR A on temp 2. I mean, I guess I don't know that we can make that any faster, or at least I can't think of any way right now. And so what I'm almost thinking, the only problem with only doing 32 rows is that we know that there is the possibility that we update the top and the bottom at the same time, and so we need to update the whole thing. So this gets us back into our problem of not enough cycles to do the full update when we... So is it, I mean, can we eliminate cycles from something else? There's all this other code that we're doing for the scrolling. Maybe what we need to do is what I talked about previously, where we will, right now we're doing a lot of recalculation of location into the meta tile map, the location in the map that we are pulling the row from, the meta tiles. And maybe that's going to be what gives us the cycles back, is we start caching that data instead of recalculating it every time. Because what happens right now is we say, okay, if we've gone 8 pixels, then we need to get to the next, we need to load the next row, and then we then check, okay, did we hit the end of a meta tile, or are we just in that same meta tile that we were in before? And then we recalculate the offset into the map position based on the meta tile value and stuff. And I think that's going to save us some time if we can cache that, so we don't have to relook that up every time. Obviously we need to look it up once for the first time we're looking at that meta tile, but we don't need to look it up 4 times, which is what we're doing right now. Or we're not looking it up, we're recalculating it, so we don't need to do that. So that might save us some cycles. And then oops. Why is that? Compare paused branch if equal to process game. Oh, because it's, yeah. Move those. Not that really. That saves us a few cycles. That's not going to save. That's not going to save the update. $27.85. We're actually really close. Of course, the problem is that we're so close that as soon as we add anything, it's going to break it again. So we're at 600 cycles for just our normal processing of the NMI. Seems like a lot. I think this is faster to do than the load A. I think that's what I saw somewhere, that bit is fewer cycles, 3 or 4, and load A. 4, it's the same. Oh well. We don't need it to be in there anyway, though. So let's see. That's doing our DMA. Could we do that at the end? So we can get all of our scrolling stuff handled before the redraw starts. I don't know that that's going to work right. I don't know why it keeps loading the save state. Well, it's less problematic when it happens now, because you can see that the status bar did drop a little bit, but wasn't quite so bad. And I believe we're just burning some cycles in the interrupt right now. Let's see. We were doing that so that the status bar draws properly across the screen. that didn't do what I thought it would. Okay. We still need to burn those cycles to make it draw properly without that artifacting. So I think the next place we attack here in getting this working, because I can't think of a way to make this more efficient at this point, is, like I said, the recalculation that we're doing here with these adding and multiplying and all this other stuff that we probably don't need to do unless we're switching to another row or another metatile row, so we can store the lookup in memory somewhere, and just reference that until it's time to update it, and then we'd be able to maybe get it in under the clock here. I mean, there's still something not updating quite right here with the way it's updating the attributes, but it is updating the attributes, so we're getting at least some partial functionality here. Let's see. I think it's because the attribute index is probably wrong. Yeah, so it's the problem is right now, if we load the attribute index, let's see. So when we load the attribute index, if we were in split mode, we're off by 16. If we're not in split mode, then we're off by 8. So let me get this out of here. So let's do this. So we don't actually need to do this here. We do this here. So load a attribute mode, compare compare it with split, branch not equal to no split index update. No split index update. Right, so here we need to load the attribute index and then set the carry and subtract 16, because we'll have essentially incremented to the end of the row that we were interested in. And we need to go to the previous row. So that's that, and then we want to and 3f to wrap it properly if we did wrap, and then branch if carry is clear to that so if the carry is clear, we've flipped mode. So actually update attribute PPU. Branch if carry is still set to update attribute PPU. And that's where we're going to go anyway. So load a 0, or let's do this, load a attribute mode, no split, stored in attribute mode. When we get to that point, we want to load 30 into the attribute index, because that will be the next row that we need to update. And then similarly here, we want to set the carry. Well, we want to load attribute index, set the carry, subtract 16, right? Right. Actually, so what's the difference? If we're not splitting, we've updated the row, and that's all we have to update, so we now go back to the previous one. If we're splitting, we've updated both rows, and then we're going back to the previous one. Actually, is that right? The top and then the bottom, and so then we want to, so we updated the top and the bottom, and so then we want to go back to this row and update the top and the bottom of this. Yeah, and then for this we just want to update the whole thing, and we want to go back and update the whole thing. So these are actually the same. Otherwise, let's load A with attribute mode, your one, store A attribute mode, compare it to attribute mode split, branch if not equal, to set no split index, load A. So this is going to set the, so if it's in split mode, it was not in split mode before, so we want to set the index to 3.8, and then jump to update attribute PPU, and this will be set no split index. Load A30, update attribute index, jump, yep, and then actually get rid of that jump. Oh, it looks like we're close. It's still not exactly right, but it's actually running in a decent amount of frames here. And if we can do some caching on the calculation, we might be okay. I think we're just now updating this wrong. If we're at 38 in hex, we're updating that, we're subtracting that, subtracting from here, we're wrapping, and then we're updating that. Here we're just doing the full row update. We're incrementing this here, we're incrementing that there. We can even just do this here. And then we're wrapping this. And then we're storing it. And then we're saying, okay, once we're done, if we needed to update the attributes, go to update the attributes. So we're going to load the index and we're going to subtract 16 from it, because we'll have added 8. So if we subtract 8, we're going to go back to the row we were on. We want to go back to the row prior to that. And then we want to do an AND to clear up any wrapping. If the carry is set, then we didn't go into negative because it didn't have to borrow. So we just go right into here. Otherwise, we're going to load the mode, and then we're going to flip it to whatever it wasn't. So if it was in split mode, it would become no split mode. So if it's in split mode after the flip, then we want to set branch if not equal to set. Wait a minute. Let's do this. That's the no split index. Well, yeah, that should be fine. So if it's not split, then we're going to go to the no split index, which should be 30. Otherwise, it's going to be 38. And then we're jumping here. That looks okay, but I'm at this point exhausted, and obviously something is still not quite right, but it's gone from being a total disaster to just a slight disaster. Let's see what happens when it gets to the end. So it's trying to load those green palettes, but it's not working. All right, well, let's wrap up here. We're close. We're really close. This ended up being a lot harder than I thought it was going to be, but let's wrap up for tonight because it's been a long one. Thanks for watching. For those of you on the stream live, I appreciate it. The Holy Movies, I am working on an NES game here in assembly language. Yeah, thanks for watching, and I will see you Thursday, 9 p.m. Eastern. As always, if you have questions, feel free to comment on the video, the recording that I'm going to post on YouTube tonight. And you can always find me on Twitter at Clairvis. I'm also on Nintendo Age. There are a lot of other people on Nintendo Age who are excellent NES programmers. You should definitely check it out. And I'll see you Thursday. Thanks for watching.